guys. All right. So, just got back from my son's baseball game, and guess what? Their team won. It's their second game out of what is it, 6 now? But they were so excited, and it's so cute. And so it's been a fun night. It is Thursday night right now. It's been a busy day. So my only break today was going to the ball game, and it was cold out, but it felt good. And so yeah. But anyways, here we are, 3.9 day one, number one. So we need to, what does it say? Find dy dx. And it also says, remember that you can use ender, which means your calculator, to support your computation. So you can always use your graphing calculator, but that gets a little tricky sometimes. So, but you can. All right. So, and also the odds are always in the back of the book. So you can always check the answers in the back of the book. I don't know if you guys know that. I haven't mentioned that before. I automatically assume that you guys know that because I always knew that growing up. But I know that being a student now is way different than it was when I was a student. So, and I'm not that old, but it still was a while ago. I graduated in 2003 from Sultana. But anyways, okay. So number one, we need to find dy dx. So we need our little cheat sheet. Okay, so of e to the x, it is itself, but we have to make sure that whatever is in the exponent, we take the derivative of. Well, it's just an x, and the derivative of an x is 1, so that means that this is just itself. Isn't that easy? Oh, actually, I should write it like this, because we took the derivative, because of course it equals itself, but the derivative also equals the same thing in this case. Okay. Number 3, because we're doing 1 through 9 odds right now. Number 3 is y equals e to the negative x. Okay, so same type of thing, but we have to take the derivative of the exponent there. So when we do that, well, the derivative of a negative, oops, why do I keep doing that? Y prime equals. The derivative of a negative x is just a negative 1, and then we'll just have the same exact thing, e to the negative x. So negative 1 e to the negative x. That's it. All right. Number 5 would be the next one. Number 5 is y equals e to the 2x over 3. In other words, 2/3 x. Well, we need to take its derivative. So the derivative would be, we have to take the derivative of that exponent. The derivative of a 2/3 x would be 2/3, and then we would have the same thing, e to the 2x over 3. So the e's are pretty easy. You just have to remember that they're themselves. You just have to make sure to take a derivative of the exponent. Number 7 would be the next odd, y equals x e squared minus e to the x. Okay, well, let's see. E squared would be a constant. So I want to take note of that, because we could type in e to the second power in our calculator and we will get a number. So this is technically a constant. So even though I have x times e squared, you could use product rule on that and you'll still be fine. You'll still get the correct answer, but you don't have to. That's actually an extra step. So when you see my key, I actually did product rule, but I am noticing now that, hey, that's a constant. We don't need to. Let me show you on the calculator. So if I have e is right there where the divide symbol is, to the second power, it's just a number. An irrational number, but it's a number. So it's just a constant. So when I take the derivative of x, it's just pretend that e squared is in front, that's its coefficient. It would just be e squared minus the derivative of x is just a 1, so it's just a 1 e to the x. So the answer is just e squared minus e to the x. And if you did it using product rule, you get the same thing. Number 9, y equals e to the square root of x. Okay, so now we have a square root up there. Hopefully you guys can see this yellow. Yeah, I think you can. All right, So, well, what does the square root of x mean? It means it's x to the 1/2 power. So when we take the derivative of x to the 1/2 power, we're going to have a 1/2 x, and then we have to subtract 1. 1/2 minus 1 is negative 1/2. And then we'll have the e to the square root of x. Okay, well, let's simplify that a little bit more. So we'll have, let's see, this is going to drop like it's hot because we've got a negative exponent. This will stay up, but that 2 is already in the denominator. So I will have only in the numerator e to the square root of x power over 2 square root of x. And that's the answer. Okay, number 11. Oh, I don't want to use orange underneath orange. Let me switch the order there. Number 11. Oh, we didn't have to do number 11. Oh, I did that on my key too. Ah, well. Okay, so 15 through 19, so we'll put 15 there instead. Number 15 is y equals the natural log of x squared. And we need to take its derivative. It's under the same set of directions as 1 through 9. So we've got a natural log, and whenever we have a natural log, it'll be 1 over whatever the x is. Okay, and the x is whatever is in the natural log. Okay, so our x is the x squared there. So we're going to take its derivative. So we'll have y prime equals, well, the derivative of an x squared is a 2x. And then this will turn into 1 over x squared because that's the input value. Okay, well, let me use a different color. Every time I change up something, I want to make sure to use a different color to show the change. So this can cancel. So y prime is going to equal 2 over x. Now here we got to be careful because, and you know what, also over here, if we have a variable in the denominator, we got to be very clear that x cannot make the denominator 0. So x has to be greater than 0 here. And same there, we can't have a denominator become 0 because that's undefined. So x has to be a number greater than 0. Okay. All right. Next one, I'm trying to put my pens in order. Number 17. We have y equals the natural log of 1 over x. Okay, well, another natural log 1, and it's a 1 over x this time. And we got to be careful because 1 over x, we need it to be in as an exponent. We can write this as x to the negative 1 power because we're going to have to take its derivative because we have to do the chain rule, take the derivative of the inside. So the derivative of x to the negative 1 power would be a negative 1 x, and then we have to subtract 1 from that, so that would become a negative 2. And then the natural log becomes a 1 over the input. We'll just leave it as x to the negative 1 power. Okay. And I know sometimes it helps visually if we just do the whole fraction bar thing, but you don't have to do that. I remember my college teachers, my professors, they didn't like it when we did that. They wanted us to get used to seeing it, not having to do that. All right, so this needs to be dropped like it's hot, and this needs to be thrown up so that we can invert them. Okay, and then negative 1 times 1 is obviously going to be negative 1. So we'll have a negative 1. This x comes to the top. This x comes to the bottom, and it's an x squared. Okay. It helps when you do that step because it might be confusing on what cancels and where it ends up in the top or the bottom. So we'll have a final answer, y prime equals negative 1 over x. I hope my commentary and walking you through how I think through a problem helps you learn how to think through a problem. So I try to include what my thought process is so that you can understand what my brain is doing as I'm going through these problems. Because sometimes the way I'm thinking about something is not the way that you're thinking about something. And vice versa. I've had students show me quicker and better ways to do math problems before. So, all right, now we've got a double natural log, a natural log and a natural log, okay? So this is our inside this time, the whole natural log of x. So we have to take the derivative of that. Well, we know the derivative of the natural log of x is 1 over x. Times, now we have to do the derivative overall, and that is 1 over, well, the inside is natural log of x. Okay, so be careful about not overthinking these problems. Don't overthink them, okay? They're easier than they seem. Okay, so y prime equals, well, 1 over x times 1 over natural log of x will just be 1 over x natural log x. That's it. These are not bad at all. So that was the 15 through 19. Now we need 31, and I need to look and see how much room I need on that one. I need some room on that one, so I'm going to flip it over to the back. Okay. So 31, we're, what does it say? I wrote down notes, but I don't remember what it says. It says a line with a slope m. Okay, so we have a line with slope m, passes through the origin. So it goes through the point 0, 0, and is tangent to, so tangent to y equals the natural log of 2x. I'm just taking notes on what is given. What is the value of m? So what is m? Okay. So let's start with the function that they gave us. They gave us y equals the natural log of 2x. Well, when we're finding slope, that means we need to take a derivative. So let's start with taking the derivative of this function, since it's tangent to this. So y prime equals the derivative of the inside of 2x would be a 2 times the derivative of natural log is 1 over the inside, which is 2x. These 2's will cancel, and we'll get y prime equals 1 over x. Okay, but this is the point that it's tangent to, or that it goes through, and if I were to plug in a 0 for x, I'm in trouble. Can't plug in 0. It doesn't work. I will get undefined, and then I'm stuck. Okay, so now I have to follow a different route. Well, they're saying that the tangent line, we don't know its slope, it's m for right now, but it goes through the origin. So going back to that, we can think in general, y equals mx plus b, right? Well, for this particular line, we don't know the slope, so it would be mx, but we do know that it passes through the origin. So since the y value is 0, that means that, and the x value is 0, that means that this is the y-intercept. It's crossing through the origin. Okay, so let's put, we're at the origin. Okay, all right, so that means that y equals just mx. So what we can do with that, we can use this to our advantage. Let's solve for m. So that means we need to divide both sides by x. So m is going to equal y over x. Okay, so I have the slope in terms of x and y, pretty much. Okay. Well, now, since I know that y prime equals 1 over x, and this is a derivative, so that means that it is the slope, that means I can take those and set them equal to each other because they're representing slope. They're both representing the same thing. So 1 over x, I could set equal to y over x. And we have a fraction equal to a fraction, so I like to cross multiply. That wasn't a timeout, it was a cross multiply, but it made me think a timeout. All right, so we have x equals x times y, so xy. And then if I solve for y, I'd have to divide both sides by x. I don't normally show that step, but I want to this time because x divided by itself is a 1. So I know that y is going to equal 1. Okay, So now that I know that, I have something that I can set, or I could plug in for y. This is a regular y, not the derivative y. Okay, so I can go to the original equation and plug in that 1, and that's going to help me find some things. So the next step will be to substitute. I know this is a long problem. And there's a lot of thinking involved on where to go every time we get stuck. So I have to substitute again from the original. Okay, so the original is y equals the natural log of 2x. All right, so let's plug in the 1. So we'll have natural log of 2x equals 1. And we need to solve for x, okay? Because we have y already. If I can find x, then I can find the slope, and that's what I need. So remember that warm-up where we had to rewrite from logarithmic form to exponential form or vice versa? Remember how it's all about the base? And on a natural log, the base is an e. We'll do the roundabout. So e to the first equals 2x. And now we can solve for x. How cool is that? Divide both sides by 2, and we'll get x equals e to the first, which is just e, over 2. Okay, so now I have, that's going to be a decimal, and that's okay. But now I have an x value and a y value, and now we could take these and plug them in, and we can find the slope. And it's going to be beautiful. So we'll have m equals, the y value is 1, over the x value is e over 2. So dividing fractions is easy as pie. Flip the second and multiply. So 1 times 2 over e is just, well, let's undo the drop it like it's hot. So let's make it 2e to the negative 1 power, because then it doesn't have to be written as a fraction. And there's my slope. And that is the correct answer. If you look at the book, that's the answer it gives you. Okay, so all of that. But they all are related, like the slope and then slope formula, because it's linear, because it's talking about a line. So using something like algebra 1, but relating it to derivatives, and then using that relationship between a derivative and the slope y equals mx plus b form to find a y value, and then using that to go back to the original and use it to find the x value, and then you have enough information to find the slope. They're all intertwined, they're all related. This is such a good problem. It has it all in there, and it's all pretty basic stuff except for the derivatives. Okay. All right, number 35, I think I can squeeze down there, so I'm going to attempt to. All right. I used so many colors, I'm back to the same one I started with on 31. All right, number 35. It says find dy dx of y equals x to the negative square root of 2. Okay, well, this is a base of x. So you might think you might need to use one of these, but that a value is just a constant to the x power, so with a variable exponent. So that means that this is just a basic power rule problem, finding dy dx. Okay, so y prime is going to equal, well, just use power rule, just drop down the exponent, or yeah. So I'll have negative square root of 2 x, and then we have to subtract 1 from that exponent. And that's it. Kind of nice. Your normal problem. Okay. And actually, it did say to find dy dx, so when we take the derivative of y, it would just be a 1 dy dx. So I guess I should write dy dx equals instead of y prime equals, but same thing. That's technically what it means. Okay. All right, and that is day 1, I believe. Yep. All right, there you go.